Hey everyone, today we are continuing on with the Pythagorean theorem, and now we are going to use the Pythagorean theorem to solve for a missing side of a triangle. Today we're going to focus on solving for the hypotenuse of a right triangle. So please remember that the hypotenuse is always the longest side of the triangle. It is also the side that is directly across from the right angle. Okay, so just a quick refresher that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are always the legs of the triangle and c is always the hypotenuse. Okay, also quick reminder that when we use the Pythagorean theorem, we have to square numbers and take the square root of numbers. So squaring a number is multiplying that number by itself, and taking the square root of a number is determining the two factors that are the same number that will multiply to the number underneath the square root. All right, so let's look at the first example. Here we have a right triangle. As you can see, we are solving for the hypotenuse. I did not give you the length of the hypotenuse, and I know that this side is the hypotenuse because if I drew an arrow from my right angle, this is the side that is across from that right angle. So my two legs are 13 and 8. All right, so I wrote the steps over here in yellow text boxes to help you complete these. So step 1 is to plug the legs of the right triangle in for A and B. Remember, like I just said, A and B always have to be the legs of the triangle. It does not matter which leg you call A or which leg you call B, as long as they are A and B and not C. So for A, I'll plug in 13, and for B, I'll plug in 8. After you plug in those legs, you then have to square each of the legs. So if I square each of the legs, 13 squared is 169 and 8 squared is 64. Then we gotta add these two legs together, which is step 3. So 169 plus 64 is 233. So we have 233 is equal to c squared. Well, guys, just remember the Pythagorean theorem is an equation and we have to solve this equation. Now, when we solve any equations, our goal is to get the variable all by itself, to figure out what the variable is equal to. However, this c is not all by itself yet. It has a squared, so I got to get rid of that squared. So I do the inverse operation of squaring a number, which is taking the square root. But if I take the square root of one side of the equation, I must take the square root of the other side of the equation. So that's what we do. We take the square root of both sides. So I'm going to take the square root of c squared, and I'm going to take the square root of 233. So the square root of 233 is going to give you a decimal because 233 is not a perfect square. So there does not exist a number that you can multiply by itself to get 233. So if you look at this text box, I told you guys, please round your answer to the nearest whole number. So if you guys were to plug in the square root of 233 in your on a calculator, you would get about 15.264, so on and so forth. Again, we're rounding that to the nearest whole number. So this will round to be 15. So the length of the hypotenuse is equal to about 15, rounded to the nearest whole number. Okay, next one, I gave you another right triangle. Again, we got to solve for the hypotenuse. So I gave you the two legs. The two legs are 10 and 7. So I plug in 10. I'll plug in 10 for A, and I'll plug in 7 for B. After you do that, you got to square each leg. So 10 squared is 100, and 7 squared is 49. Then you have to add 100 plus 1 plus 49, which gives you 149. You are then going to take the square root of both sides of the equation to get that c squared, or that c all by itself. So the square root of 149, again, 149 is not a perfect square, so you're going to get a decimal yet again. Again, rounded to the nearest whole number, and when you take the square root of 149, you get about 12.206, so on and so forth. So if I wanted to round that to the nearest whole number, we would just get 12. So length of this hypotenuse would be 12, rounded to the nearest whole number. Okay, next one, we have another right triangle. It's just positioned a little bit differently than the first two. But again, we're solving for the hypotenuse. We're solving for that longest side, the side opposite of the right angle. Okay, so our legs are 7 and 19. Okay, so then we have to square both legs. 7 squared is 49, and 19 squared is 361. Then add these together, get 410. Okay, so now we have 410 is equal to c squared. We've got to get that c all by itself, so we're going to take the square root of both sides. Square root of c squared is just c. And then the square root of 410. 410 is not a perfect square, so yet again, we will get a decimal. But again, we're rounding it to the nearest whole number, so I'm just going to round that to 20. So we get c is equal to 20, which gives us the length of the hypotenuse being equal to 20. And again, you guys know the hypotenuse has to be the longest side of the triangle. And if this is 20, that does in fact turn out to be true because 20 is greater than 19 and 7, as it was in the other two examples as well. Okay, next one, we're solving for the hypotenuse. Again, I gave you two legs, 11 and 3. So step 1, plug your legs into the Pythagorean theorem. Again, make sure you're plugging them in for A and B. Okay, now you're going to square both of those legs. So 11 squared is 121 and 3 squared is 9. Then add the two legs squared together, which is 130. We then need to take the square root of both sides to get c all by itself. So the square root of c squared is simply c, and the square root of 130, again, 130 is not a perfect square, so we will get a decimal that we're going to round to the nearest whole number. It's about 11.4, so I'm going to round that to 11. Again, you'll notice that we know that the hypotenuse has to be the longest side. The reason why it's not here is simply because we rounded this answer, but more exactly, the length of this hypotenuse is about 11.4017, so on and so forth, which would be greater than this side 11. So it would be the longest side. Okay, we'll do one more. All right, another right triangle. I gave you two legs, 10 and 20. So let's go ahead and plug those into our Pythagorean theorem. You guys will notice I plugged in 20 for A and 10 for B. You might have plugged in 10 for A and 20 for B, which is fine. We'll get the same answer. Okay, 20 squared is 400 and 10 squared is 100. We then need to add those two numbers together. 400 plus 100 gives us 500. Okay, then we got to take the square root of both sides. Square root of 500, yet again, you will get a decimal rounding to the nearest whole number. I'm going to round it to 22, and the square root of c squared is simply c. So we get the length of this hypotenuse being 22. All right, guys, there's some other examples that you can look at to help you complete the assignment for today, but you're going to be doing the same thing, solving for the hypotenuse of 10 different right triangles. Okay, guys, as always, if you have any questions, please ask.